Hello everyone and welcome to our first demo video of our Octopus VAR, a product from Octopus Cybersecurity. I'll start with a 5-minute description of our solution and then we dive into our actual technical solution. This is a recorded presentation, so please comment under the video or at the end I'll be providing an email. If you can send me your questions or any clarifications, feedbacks about the video, about the product, it's very helpful. Thank you in advance and thank you for your time for watching this video as well. So what we do, what does Octopus VAR do? We noticed through our as our security implementation engineer and support, we noticed that security managers and risk managers as well wants to validate their security posture of many different network devices that they have deployed within their organization, and as well the process of deploying a new product within the organization. So these settings are based from security best practices, baselines, international standards, local regulations, and even organization policy. So how to check those, especially that in the security department, which is different than the operations team, they may not have the deep technical skills that the operations team have in order to dig down into the details. What did they usually do? They usually go back to the vendor, get the best practice, read, research, all this stuff, outsource even. All this stuff is done in the process of validating the security posture of the network devices. This is we come here into providing templates to the customer based on best practices, feedbacks from subject matter experts. We build rules for each vendor and we automatically validate these rules against the target device and make sure that this target device is compliant to a certain percentage, and definitely report to the security manager and or risk manager. In addition to this, we saw during our experience and practices within this field that there is a non-compliant practice in terms of operational changes. So people or engineers tend to modify these security baselines that we put from the beginning, maybe because due to troubleshooting purposes or some testing is being done. And this is most of the cases the engineers forget to revert back or keep the setting for a long time where the security managers are not aware of this serious risk. So also we're targeting this problem or this challenge by reading in real time the operational changes and validating the specified rules or the assigned rules to that particular device if a change happens, and make sure that this change did not impact our setting or baseline. So this is in a nutshell, and we will now proceed with a demonstration of our solution. I'll be sharing my screen. And here you go. This is our graphical user interface where the landing page will lead you to a dashboard with the set of widgets, built-in graphical graphs that represents the different statistics that are being collected. For example, if we start with this graph which shows the percentage of compliance, this is very important to give you an indication of your security posture within your environment and where is your direction. You can drill down to see the devices per device, what is the percentage as well, so you make sure that you are attending your concerns and percentage and make this as much high as possible. In addition to this, you'll find risk scores, let's say the number of high level violations, and this is a risk score is based from this criticality of the target device, a server maybe, a network device, security device, uh, are different in terms of criticality. So we label them as well as based on the particular rules that we trigger and validate. And these rules have different severity levels. So that also will be calculated and represented in a risk score where you are able to directly go to the particular rule, particular device and fix the high ones at early stages. In addition to changes that is happening on by daily basis, violations also on average, we have reports, violations per device, and the status of each device. In order to accomplish and get these statistics, we go to devices. And here we have in our lab a list of devices that are already integrated. Like we have CentOS, Cisco, Switch, 5 firewall, web application firewall, Palo Alto, it's a firewall, proxy, Red Hat, Windows, normal Windows PC, and Windows Server. So these what we have deployed here as testing scenarios, and you can add a device as simple as that by defining which type of protocol it will communicate. So Octopus VAR will communicate with this target device through SSH, through WinRM for Windows, through API URL if it is there, if it is an application maybe. Also, it can get the configuration that we require. So based on commands, most of the devices use SSH. And here you set that group, the criticality that we talked about, the set of rules, we'll talk about them in a bit, and some tags that you can put to identify and make reports at a later stage. And if you want, you'll see also the compliance percentage for each device, and you can drill also to see more details of those devices that are integrated. The brain of our solution lies here in something called, we called it MSB, stands for Minimum Security Baselines. So it is a set of rules, and these rules are grouped through different types. So we have the most important type, like which product vendor that this rule applies for. So this is the most important grouping. We also group it by compliance. So some rules are based on from CIS, others from PCI, or both at the same time apply. Some rules apply to different sectors. So what is applied for banks may not be applicable for government, and vice versa. Severity that we talked about, it's very important to identify each rule, what is the severity level. And in addition to some customized groups like locations based on the organization and what type of device that we have, firewall, server, switch, etc. Plus, we have this option to provide using customizable rules. So maybe some organizations may not require all the CIS groups or all the best practices rules. So I need to be selective and select the ones that are important for me. And I have the option as well to create my own rule. So rules, if we dig down to some one of the rules that we have in the list, so it is normal description, severity, you define variables, uh, the command that will be executed on the target machine and the expected output where we compare. So we have option to also build nested conditions as well in order to verify that this is actually what we need if we execute this command. And here this grouping that we talked about, we have an option to remediate. So for this particular command there is no script, but for others we may integrate as well. So in order to execute these rules, we have two main functions that we talked about in our introduction. So something called validate and analysis. Validate is the on-demand process where we go, connect to the device and execute the list of rules slash commands and verify them. The result will come to here as fail or pass. So if it is pass, this means the rule applies. And what is expected as an output is here as pass. Whereas if it shows fail, then the expected output does not match what is inside the rule and it will show fail. This is the real time, the on demand. Whereas for analysis, it shows the real time. So any change that we talked about in operational life cycle of the product, any change will get a log and will trigger a validation process, which will validate against the rules that we assign to that device, and the results will be similar to validate. So we have two options, the validate the on-demand and analysis is the real time. So let's deep dive into it and test it. So we have here a firewall, a web application firewall, and we'll test with. So we try to log in. Oops. Okay, it took me directly to what I wanted. A simple example which is related to password complexity. So we need to make sure that a complex settings are there. We don't look into the passwords themselves, but we make sure that those settings comply to, for in our example, we are based our rules from CIS benchmark recommendations. So if we go here and search, let's say, for password, and we'll find these related password rules. And let's take an example, the 12 characters. So it is failing, and here it is not. So maybe the validation is old. I will run this one now and see the result. I have to select the device, list of rules again, and select this one. I want to validate. Either I can choose, if I don't choose anything, then it will validate all, otherwise it will validate this particular rule in our demo. And you will see that 12 characters, it is now passed. that was related to F5. So we give another example related to Windows. So we have Windows server, and let's check some rule. And I have this server here. Okay, this one also I'll need to put the password. So in this server we have registry keys, and we have, let's say we'll take an example like inactivity timeout in seconds. So this is related to let's search for it. Inactivity, what is the status? Inactivity login. So machine inactivity limit is 900 seconds, but not 0. So it is failed now, and this is okay. This is the value 380, which is different than 900. I will modify it and put it 900. 900 in hexadecimal is 384. So you will see here 900. I change it now, and then I'll go back here, and yeah, it is running validate because we're enabling the real time, so it is automatically validating, and we're supposed to get a response in seconds, because now in this case it is running all the Windows rules. So if we take out this to see how many rules are there, now 84. Let's go back to inactivity, and at this page it is still failing. I will validate again. To modify this value, so that is passed. Now I'm validating only one single row. Okay, this is related to validate. We'll move into analysis, which is, as I mentioned before, it is the real-time analysis. So when there is a change, we're supposed to get it here reported. So if we search an activity, and we'll find it now pass. And if we take this one, we'll find that it highlights the ones that are changed from fail to pass. So that's the point here. Okay, we can give another example, which we'll go back to F5 and see what is the status of our password on this page. Yeah, so it was fail, also went to pass the 12 characters. And let's now change to 10. We'll violate our rule and make it 10. So what we will expect now, we will expect that this rule will change back to fail. And we can also see the logs here. to make sure that things are moving properly, executions process is going through as expected. Okay, validation is going on. You can see different settings are there, backups. In the meantime, let's go back to a 5 analysis, password to see the status. Now, yes, the 12 characters, this one is fail. Okay, but I need to fix now. So if you see here, the status is 10 and I need to fix, I can have the option to fix from here as well. By selecting remediate. So in the remediate option, it will give me the different the value that I need to set. So I just execute and we jump to the GUI of the other device and just refresh the page and you'll see the value has been changed to 12. At the same time now, because we change it, this is expected to get refreshed and pass should change to pass. So I'll select this one and this time we'll wait a little bit for it to change to pass. As you can see now, it is changed to pass and highlighted because we have checked it here. That's the real-time verification remediation of the solution within the Octopus VAR integrated. So in addition to validate analysis, we have reporting where you can also generate built-in reports based on details and executive reports. And I have one that is open already here, generated and open, and this is a template of a sample of what you would see, and it is all there in the also dashboard. That's it. I think from the demonstration point of view, thank you for listening. Thank you for your time. Don't forget to email me. This is my email address. And I'm looking forward to hear from you. Thank you.